Hi guys, so the point of this tutorial is just to give you a brief overview of calculus and first principles and derivatives. So we'll start off by defining what we mean by a derivative. So we all know that if we take a straight line and we look at the gradient of the straight line, the equation of this line is y equals mx plus c, where m is our gradient, right? And m is simply equal to, and we'll define that now. So m is equal to the change in our y value over the change in our x value. So if we have x1 over here, x2 over here, we have y1 over there, and we have y2 over here. And that can be written as y1 minus y2 over x1 minus x2. Now you could write it as y2 minus y1 over x2 minus x1, makes no difference. But the point is this gives us the slope of this graph. So how steep this graph is going. The problem with that is that's a straight line, and it's all great because the gradient doesn't change. Now if we look at a line that is not straight, so an exponential or a parabola or anything along those lines, we look at the same thing and we say, well, that's our x1 point, that's our x2 point, we have our y1 point and our y2 point. So it's exactly the same as the straight line, except now we want to find the gradient, but the gradient is not as simple. So if we take a straight line and we join those 2 points, we can say, well, the gradient of that line is equal to, once again, the change in y over the change in x, which gives us y1 minus y2 over x1 minus x2. Same as before. But the problem is that only approximates the gradient of this line. It's not actually the correct gradient. So how do we make it the correct gradient? Well, if we take these 2 points, so if we take that x1 and that x1, and we bring them closer together, what we're going to end up with is we're going to end up with them so that they're so close together that they're effectively the same point. So if I can just draw this, we have x1 over here, x2 over there, we have y1 and y2. And now if we look at the gradient between those 2 points, we can see that it's a lot more accurate for that region. So how do we mathematically do that? We need to bring these x1s and x2s close together, so close together in fact that they're almost the same point, so that we can accurately approximate that line. So if we redraw this in a way that makes mathematical sense, let's change to black, we can say, well, we've got the same graph as we had. We have our x1 value and we have our x2 value, but instead of calling it x2, let's simply say this is x1 plus some h. What is that h? That h is the distance between these 2 values over here. And if this is going to be y1, instead of saying y1, let's call this graph f of x. We can say that this graph is f of x, x1, x, and this one over here must then be f of x plus h. So this one we're going to write as f of x plus h, because that's the x value at that point. And what we need to do is we say, okay, what is the gradient? Well, the gradient, m, is equal to delta y over delta x, the same as before. But this time, instead of saying y1 and y2, we say, well, f of x1 minus f of x2. So we say, okay, it's the change, so we can say f of x plus h minus f of x divided by x plus h, which is this bottom one, minus x, which is that bottom one. Now it doesn't actually matter which way you do it, where you can say f of x minus f of x plus h divided by x minus x plus h. It doesn't make a difference. But what we end up with is something that looks like this: f of x plus h minus f of x, all that divided by, and you'll notice that this x and that x cancel out. So we're left with h. And we've now got what almost looks like the first principles formula. So as I said previously, what we want to do is we want to figure out the gradient at some point. So I'm going to choose that point, and I'm saying this is a tangent line to this graph, and the gradient of this tangent line when these two x points are so close together that they're effectively at the same point. Now we know how to do that mathematically. We can do that by taking the limit. So we take the limit as what? As h tends to 0. In other words, as this distance between the 2 points becomes so small, the points are effectively at the same point. So the limit as h tends to 0 is equal to, or the limit of, let's say the gradient of this line is equal to the limit as h tends to 0 of f of x plus h minus f of x divided by h. And now we have our first principles formula. So let's just highlight that. This is our first principles formula for finding the gradient of a graph, of any graph, at some point. So we can say, well, let's find the gradient at that point, find the gradient at that point, that point, that point. It doesn't matter. At any point we can find the gradient using this formula, and this is known as first principles. So how do we go about actually using that formula? Well, let's look at an example. The first example, well, okay, there's three examples. There are three typical types of examples that you can use with this first principle that they can ask in a question. So the first type of example is just a basic, let f of x, let's just put example 1, f of x equals, I'm going to go with the simple one, 2x squared plus 4. Okay, it's very basic. This is the most simple type of thing they can do, asking a question like this. And what we need to do is you say, okay, well, we first need to write down f of x plus h, because if you remember the first, we had two things. We had f of x and we had f of x plus h. So we first write down f of x plus h, and that's, you simply substitute x plus h into every x value. So every time you see an x, you substitute x plus h. Don't forget your brackets, plus 4. And we simplify this out. It's always good to simplify it out before we plug it into the big formula, otherwise it just becomes one big mess. And we get 2 x plus h, and I'm just going to do it x plus h in as many steps as necessary, but you can skip steps, it's not a problem. We end up with 2x squared, that one times that one, plus xh, that one times that one, plus xh again, that one times that one, plus h squared, that one times that one, and then obviously plus 4. We simplify that and we see we get 2x squared plus 4xh, right? It's that one plus that one is 2xh times 2, which is 4xh, plus 2h squared plus 4. So we've now got our thing. Now it's much easier to simplify outside of the big equation than it is to do it inside the big equation. And then we say, well, the gradient, which is what they want, now we can write that slightly differently, and we can say, well, the derivative of x, which is the gradient, is equal to the limit as h tends to 0 of this formula, f of x plus h minus f of x divided by h. Now obviously if we just look at that limit, we can see that, well, if h goes to 0, this guy here goes to 0. If that goes to 0, then this whole thing, we have some value, call this value, I don't know, alpha, divided by 0, and that's a problem. So we can't do that. So we'll have to just simplify it, and you get a mark for this, so actually write it out. Always write it out, and don't forget your limit sign. Also, don't say equals. That is bad. You'll get naught for that. You'll get naught for the whole thing if you put an equal sign. So the derivative of x, of f of x, which is equal to the gradient, is equal to the limit as h tends to 0, and we substitute in what we did in the previous line. 2x squared plus 4xh plus 2h squared plus 4 minus, don't forget your brackets, 2x squared plus 4. All that divided by h. And now what you'll see is this thing will simplify. The limit as h tends to 0. And the best part about this is everything with just an x in it, for example, that one, and, well, that one doesn't have anything in it. Anything without an h will cancel out. So the 2x squared cancels out with the 2x squared. So we left with that one cancelling out that one. And the 4 cancels out with the 4. So we left with 4xh plus 2h squared. And you have to be left with just h's, otherwise this whole thing is not going to work. So it's very important that if you don't get left with h's, you've done something wrong. We then say, well, the limit as h tends to 0. Now still, if we put h to 0, we're just going to get 0 over 0. That's the problem, you can't divide by 0. So we take h out as a common factor. We get 4x plus 2h, all that divided by h, and now we see those h's actually cancel. And now that we don't have a divide by 0, we can actually substitute 0 into the remaining h's. And what we get is we get 4x plus 2 times 0, which is just 4x. And that's our answer. The derivative of that function is just 4x. And we can do that using the so-called quick method, which we'll discuss in a little bit detail later. But if f of x is equal to 2x squared plus 4, I think that was the original equation, let me just double check, yeah. Then we can say, well, the derivative of x is equal to this 2 multiplies by that, so we end up with 4x, and then just 1 at the top, and this one disappears. We'll discuss that in a little more detail later, but we see using the quick method, we actually get the same answer, so it must be correct. The second example or type that they can give us is a little bit more complicated. We say, well, f of x is equal to, and let's take a square root. Square root of, let's not make it a horrible one, but let's say 2x plus, I don't know, 2. Make it nice. Now once again, we say, well, f of x plus h equals, and we simply, every time you see an x, you substitute x plus h. Pen's dying. And then plus 2. And we simplify that out. Always simplify it out before you put it in the big formula. 2x plus 2h plus 2. Okay, that's what we get. So we say, well, the derivative of f of x is equal to the limit as h tends to 0. Once again, write the formula out, you get marks for it. F of x plus h minus f of x divided by h. We then substitute the two things that we've just calculated into the formula, and we say the limit as h tends to 0 of f of x plus h, which is the square root of 2x plus 2h plus 2, minus f of x, which is just the square root of 2x plus 2, all that divided by h. Now we've got a bit of a problem. How do we get rid of these square roots? This and that is a problem. So how do we get rid of that? Well, what we do, let me just draw that square root back. What we do is we multiply it by something. Now you might say, well, how do we know to multiply it? Well, we know to multiply it because we're going to do this every single time we get a question like this. So when you get a question with a square root, we're going to do the same thing every single time. And we're going to multiply it by something that makes sense, because you can't simplify this as it is. Okay, so let me write this on a new line just to make a little bit more space. And we have the limit as h tends to 0 of this horrible looking thing, 2x plus 2h plus 2, minus the square root of 2x plus 2, all that divided by h. And we're going to multiply it by the conjugate. And what I mean by that is we're simply going to take whatever's in front. We're going to take this guy over here, which is 2x plus 2h plus 2. And we're going to say, well, instead of a minus, there's a minus over here. We're going to put a plus. If it was a plus, we'd make it a minus. So we simply changing that sign, and we say 2x plus 2. So we're multiplying it by that. So it's the same thing. We're multiplying this guy by this guy. Oh, the whole thing by that one and that one. Except we're changing this minus to a plus. And we can't do anything fancy, so we just got to divide by that again. So effectively we're multiplying by 1. So we haven't changed the sum because we've multiplied it by 1. And anything multiplied by 1 stays the same. But what does that actually do for us? Well, that makes life really, really nice. Why? Well, if we multiply all this out, now you only have to do this, I'm going to do this for you guys to show you, but you don't actually have to follow all these steps because it's just a waste of time. But if we say 2x plus 2h plus 2 minus the square root of 2x plus 2, and we multiply that by the square root of 2x plus 2h plus 2 plus the square root of 2x plus 2. I'm just going to write the bottom out just to complete it, and we have h times this whole bottom thing. Now the bottom thing you can just leave as 2x plus 2h plus 2. Don't simplify it out, don't do anything fancy. Square root of 2x plus 2. You'll see at the end why I say that. So what we have at the top is something really cool. We have, if I simplify it and I call this piece here A, and I call that B, then that is also A, and that is also B. So what we have is A minus B times A plus B. And what does that look like? Well, that looks like difference of squares. Because if we multiply this out, we end up with A squared minus B squared. Right? That's the difference of squares formula. So now all of a sudden, now all of a sudden, let me just take these away, we have something that looks like difference of squares. So we don't actually have to multiply all these things out, but we can say, well, difference of squares gives us, if we take this first term, multiply by the first term, we're going to get a squared, which just gets rid of the square root, the limit as h tends to 0. So that's the square roots disappear. So that at the top, what you end up with is 2x plus 2h plus 2, don't forget your brackets, minus the second piece, which is 2x plus 2. And because they were both squared, the square roots disappear. And you'll notice if you look at this difference of squares formula, there is no middle term. So it's simply a squared minus b squared, where this first piece here is your a and the second piece is your b. So a squared is just a and b squared is just b, because the square roots cancel with the square. And obviously we end up with the bottom piece, which then remains the same, h times, and like I said, we just leave that, 2x plus 2h plus 2. And it completely stays the same, yip-de-doo, 2x plus 2. Now we've got to simplify. So we simplify by saying, well, the limit as h tends to 0, don't forget that, you keep it through the whole thing, and everything that doesn't have an h in it cancels out. That cancels with that, that cancels with that. So we left at the top with 2h divided by h square root of 2x plus 2h plus 2, let me just extend that, plus the square root of 2x plus 2. The h's cancel, right? They're exactly the same, so they cancel, and now we don't have an h at the bottom anymore. And that's great, because that means we can substitute 0 into all our h's. So if we substitute 0 into everything, what we end up with is 2 square root of 2x plus 2 times 0, because the h is 0, plus 2, plus this other thing here, which is 2x plus 2. Pen is dying again. And what does that leave us with? Well, if we look at that closely, we simply see we get 2 divided by 2x plus 2 plus 2x plus 2. So it's just 2 times the square root of 2x plus 2. This 2 cancels with that 2, and we end up with 1 divided by the square root of 2x plus 2. And that's the answer. Now, what's great about this is the only trick in this whole thing is this one. This little guy here, we have to multiply by that, and you multiply by that every single time. So if you can remember how to do that, then this whole step here you don't even have to do. Obviously you don't have to do this one, that was just through explaining, and you can just jump straight to this step over here, which is great. And then the bottom will always simplify the same way, the top will always simplify the same way, and you're always going to simplify and end up with a similar answer to that. So first principles like that is actually remarkably easy. Okay, so the third and final type of first principles question that they can give you is one of the fractions. So let's just go to the next page. And so, okay, well, a third example is, say, f of x equals a fraction. So we'll have, let's go with 1 over 3x plus 5. Okay, so once again what we do is we say, well, f of x plus h is equal to, and everywhere you see an x. Now they could make this a little more complicated by putting an x squared at the bottom, but that just gets a mess. So we'll stick to this. And we see it's 3x plus h plus 5. We can expand this to 1 over 3x plus 3h plus 5. And then we simply substitute into our formula. So we say, well, the gradient, or f of x, f dash x, is equal to the limit as h tends to 0 of f of x plus h minus f of x divided by h. Always write that in. And then we substitute in. So it's the limit as h tends to 0 of f of x plus h, which is 1 over 3x plus 3h plus 5 minus 1 over 3x plus 5, and all of that divided by h. Okay, now how do we actually work with that? The only thing that we can do is whenever you get a fraction, you put it over a common denominator. And in this case, a common denominator is, let me just rewrite it over here, the common denominator as h tends to 0 is simply this guy here multiplied by that guy over there. So we multiply the two denominators together to get a common denominator. And to do that, we simply have, and I'm just going to write it all over the thing, we have 3x plus 3h plus 5 times by 3x plus 5. So we've multiplied those two common denominators together, all that divided by h, because remember it's this top piece divided by this bottom piece. So now we have this top piece divided by the bottom piece, and the top piece is simply 1 times that thing, and 1, or negative 1 in this case, times that thing. So how do we do that? Well, that means we just end up with 3x plus 5, 1 times 3x plus 5, minus 3x plus 3h plus 5. So we've now put the whole thing over a common denominator, We've multiplied the ones by the opposite denominator, and we've got all that. Now that looks big and scary and horrible and ugly, but it's actually really simple. If we look at this top piece, we'll see that everything without an h cancels, as we expect. So let's just cancel that out. Limit as h tends to 0. We cancel this out. Everything without an h cancels, so the 3x cancels with the 3x because it's a negative. The 5 cancels with the 5 because it's a negative. And you're left with negative 3h at the top. Divide that by this thing at the bottom. The thing at the bottom is 3x plus 3h plus 5 times by 3x plus 5. And all of that divided by h. So that's one thing at the top. Divide that by h. Now that still doesn't look so nice, but we can simplify that, because if we look on the side here and you take a fraction, let's say a over b over c, which is something similar to what we have. We have a fraction over a fraction. We can rewrite this to say, we know that any fraction, we can say a over b is equal to a times 1 over b. So we can say a over b over c is equal to, take this a over b times by 1 over c. And if we do that, we end up with a over b times 1 over c, those two times and those two times. So what we end up with is simply a times 1, which is just a, and then b times c, which is bc. So we end up with this nice little expression over there. And we can do the same for that. Now obviously you don't have to do this every single time. I was just going through the steps to show you how to, the logic behind it. But that means that this little h, this guy over here, simply moves. If you look at this answer over here, we took a over b over c, and that became a over bc. In other words, the c moved up next to the b. And that's what this h is going to do. It's going to move up next to this denominator over here. So let's do that. We end up with the limit as h tends to 0 of negative 3h divided by h times this whole bottom thing, 3x plus 3h plus 5. And you do this every time, 3x plus 5, so you don't even have to think about it, you just know it happens. And it happens because I showed you over here. And you'll notice that the h's cancel. And now because we don't have a divide by h at the bottom, because it's not going to be divided by 0, we can actually substitute that limit in. And when we do that, we get negative 3 divided by 3x plus 3 times 0 plus 5, 3x plus 5. And that bottom piece, let's just go to the next page quickly. That bottom piece can then be simplified to negative 3 divided by, effectively what we have here, that goes away, 3x plus 5 times 3x plus 5 is just 3x plus 5 squared. And that is the answer. So first principles is really nothing to it. There are three different cases. There's a case where you've got a square root, a normal one, and then a fraction. And regardless of what fraction you get, you always do it like this at matric level anyway. And the same for the square roots, and the normal one's just fairly simple. So anything by first principles, it's normally 5 to 8 marks depending on the type of question, but it's really not difficult. There's standard ways in which you go about doing them. So you should be pretty okay when you do something like that. Just to discuss very briefly the quick method. So quick method, and the quick method, as they like to call it in school, is really just applying some set of rules to be able to take the derivative as the method states quickly. So if you have a function f of x, and that equals, let's go with a times x to the power of n. That's a function. It has to be in the form of a times x to the power of n, otherwise it's not going to work. And you take the derivative of that, so f dash of x. What you end up with is a times n, x to the power of n minus 1. In other words, this n has come down, you multiply the a and the n together, and you subtract 1 from it. So I suppose you could put brackets around that n to say, well, it's multiplied. So if we do an example, and we say fx equals, let's go with 3x squared plus 2x minus 5, right? It's just some random numbers, and let's do that example. So we take the derivative of this, f dash of x, and what do? Well, we take this 2 and we bring that down. So 2 times 3 gives us 6x, and then 2 minus 1 is just 1. But we don't actually have to write that because x to the power of 1 is just x, so we just leave that 1 out. Then the other one, there's an imaginary 1 over here, just like I left the 1 out in the 6x, we can leave the 1 out, but we can also put that 1 back. And 1 times 2 is just 2. X, 1 minus 1 is 0, and x to the power of 0, anything to the power of 0 is simply 1. So this whole thing is just 1, and 2 times 1 is 2. So we leave that out. So effectively you just drop that x. Then what we have over here, with this 5, is actually minus 5 x to the power of 0, because x to the power of 0 is just 1. We take this 0 and we multiply it by the 5, and we end up with 0, right? So what do we end up over here? We get plus or minus whatever, 0. So we leave that out as well. So the constants fall away, and they fall away because of this situation over here. So when we do the derivative, we get 6x plus 2 from that. Just to note, other forms in which they can ask for the derivative, they can say d of dx. In other words, give the derivative of the function with respect to x. They can give it as dx, the same thing. It's all the same. It's the same as this f dash x. Or they can say dy dx. That's simply saying the derivative of the function y with respect to x. That's saying the derivative of function f with respect to x, the derivative with respect to x. So the function y with respect to x, the derivative of the function f with respect to x, the derivative of the function, whatever the function is, with respect to x, and the derivative of the function with respect to x. So it's all the same. If you see those symbols, don't get freaked out. It just means take the derivative. That is all. And that's it. Simple as that.